Today, guys, we're going to talk about quadrilaterals. Welcome to our lesson. This is grade 10 Euclidean Geometry. All the grades are welcome because these problems are done from grade 8 up to grade 12. Let us just start. So, quadrilaterals, there are different types of quadrilaterals. You've got a parallelogram. The first one that we're going to talk about is parallelogram. We talk about rhombus, rectangle, square, and trapezium, guys. Those are 5 quadrilaterals I'm going to talk about on today's lesson. Now, our first quadrilateral is number 1, parallelogram. Now, parallelogram has got so you're gonna prove, you're gonna understand today go to if you say a particular quadrilateral is a parallelogram, which features can you recognize which indeed this particular parallelogram is a quadrilateral, or this particular quadrilateral is a parallelogram. So there are many features. Let me just draw the quadrilateral in it. Here's our parallelogram, and it's got features in the parallelogram A, B, C, and D. And then we've got diagonals in it. Now, the first feature that you're gonna recognize they may say prove that this particular parallelogram quadrilateral is a parallelogram. They are saying to prove that this particular quadrilateral is a parallelogram. How will you know that this particular quadrilateral is a parallelogram? The first thing that you must write down to prove that indeed this particular quadrilateral is a parallelogram, you need to know what the opposite sides of parallelogram are equal. Opposite sides of parallelogram for palm, to save time, are equal. The opposite sides of palm are equal. I hope you can see it, guys. This means the opposite sides are equal. That means side AB is equal to side CD. And the opposite sides are equal. The opposite sides are equal. That means side AD is equal to side BC. But in this case, AB cannot be equal to BC. Can you see the mark here, guys? This is 1 mark, 1 mark, and 2 mark, 2 mark. So by the virtue of these marks here, or these signs here, if this one they're equal in terms of this sign, that means this side is equal to this side. If these signs are true on AB, therefore on CD are true also, that means AB is equal to DC. But AB is not equal to BC. Why? Because these two signs, they are true on AB and we have one sign on BC. Only AD equal to BC and AB equal to DC. Why? Opposite sides of palm are equal. Then we are done with proving that the opposite sides are equal. The second one that you might prove, it says opposite angles are equal. Opposite angles equal. That means angle A is equal to angle C. And angle B is equal to angle D. Now again, the signs again, or the arrows that we have shown on angle A. You only have one arrow here, even on C you have only one arrow. On B you have 2 arrows. On D we have 2, they're not called arrows but necessarily, for lack of a better way I can say arrows. On B we have 2 arrows, on D we have 2 arrows. Okay. This means only angle A is equal to angle C and only angle B equal to angle D. Not that angle B cannot be equal to angle C and angle A cannot be equal to angle D. By the look of these arrows here, it means where the arrows or on angles of which the arrows are the same. That means those angles are equal. Just like the sides. I get you have said AB equal to DC, but AB cannot be equal to AD. AB cannot be equal to BC, but only AB can be equal to DC. So just look by our signs put in DTK. These two signs are the same. That means these two angles are equal. These two signs are the same in terms of number. It is only one. That means these opposite angles are equal. Now, why do we say that? It means opposite angles are equal. Right? If they tell you, look at this. If they tell you in the statement, look at A, B, C, D is a parallelogram, just apply this reasons and do this on your diagram in a question. Yeah? You must just apply these steps. Another one is diagonals bisect. Diagonals bisect. Diagonals of palm bisect. I forgot the diagonals of palm parallelogram bisect. You must do that. Now, this means which diagonals? This diagonal. I'll just add E here. E for this point. Yes. That means we're gonna have BE, ED, AE, EC. Now, due to diagonals bisect, that means diagonals are equal. Check something here. You've got never 1, 2, 3. 1, 2, 3. This means what? BE is equals to ED and AE is equals to, this is just a sign to show what AE is equal to EC. It's nothing major, guys. Yeah. You can show it by many different ways, but I'm showing through this arrow, V arrow. AE is equal to EC and BE is equal to ED. That means this lines, these parallel lines, these lines, there are 3 again on BE, and also on ED there are 3 lines again. There are 3 parallel lines. These lines, 1, 2, 3. It shows what B is equal to ED, and BE cannot be equal to AE because of what? These arrows are not the same, or these signs are not the same. Just check which signs are the same. Therefore, if those signs are the same, that means those angles or sides are equal. Just check for similarities there. They are saying the one pair of sides equal and parallel, which means one pair of sides. Okay, we just talk about sides that are equal. Okay? Then opposite sides are parallel. Okay? Opposite sides are parallel of parallelogram. That means parallel lines, you know how do you show them in the diagram. Parallel lines, you know how to show them and get you guys. Parallel line, that means this line parallel and that's how you show parallel lines on the diagram. And get parallel lines. Parallel lines again. And get parallel line. Hope you can see. That's how we prove a particular quadrilateral is a parallelogram. Ne? Yes, guys. I hope you can see. Ne? I hope you can see what's happening here. Now let us do an example. Let us do an example. Ne? So, example number 1. Example 1. Example number 1, I get. Example number 1, guys. They're saying good here. DELLM is a parallelogram. DELM is a parallelogram. here's the diagram. Okay, here's the diagram, guys. D M L E. Okay. Then this must be given in an exam. Okay. They will show you in the exam what's happening. So you are given this in an exam. Okay. Now we have 2x here. We have x here. Okay. Now they're saying go to number A. Calculate the value of x and hence the sizes of interior angles. Now that's number A. So they're telling you this particular quadrilateral you see in front of you is a parallelogram, and they just learned about parallelogram here. The opposite sides of palm are equal, opposite angles are equal, diagonals bisect, opposite sides are parallel. Now you need to apply these principles of parallelogram to simplify this problem. Now you must find the value of x, and hence after you found the value of x, you need to find the angles, all the angles inside the parallelogram. You need to find all the angles inside the parallelogram. And I forgot to tell you guys, I forgot to mention that here all interior angles add up to 360 degrees. This is what you need to know before attempting such questions of Euclidean geometry. All interior angles of quadrilaterals, they sum up to 360 degrees. You must understand that, please, guys. You must know that it's a must to know that. Yeah. Now here. Now guys, let me just solve this problem. Okay, number A. What x and how gonna find x? Can you see that we have parallel lines in here? And if you can apply fun, math is fun. And if you can apply fun here, you can see parallel lines. And in terms of fun, I can see u here. I you need to find x, and x is here, x is here and here. So there's u here. Here's our u, and here's our parallel lines. And u, here's our u, and here, u. That means this angle plus this angle equal to 180 degrees. And that means 2x plus x equal to 180 degrees. Why? Call interior angles such that DM is parallel to EL. Then you simplify for x now. Then 2x plus x is 3x. Then you divide both sides by 3 and then you're left with x on one side. What is the value of x? Is 60 and 60. Then you are done with finding x. Now x is 60. And hence, you must use this value. Hence, use this value, the sizes of interior angles. That means you must use this value to find the sizes of interior angles. Okay? Number B. Let's find all the interior angles here. Actually, it's not number B, it's number A. Let's find the interior angles, the sizes of interior angles. How are we going to find the sizes of interior angles, guys? Now, angle E obviously is x angle. X is equal to 6. That means angle E is equal to 60 degrees. 60 degrees here, 60. And angle D, and here you have 2 times x. Angle D, just put it here. Then just write it on the side. So now, I don't want to make mistakes here, guys. Angle D is equals to 2 times 2x, and therefore angle D is equal to 2 times 60 is equals to 120. It means angle D is equals to 120 here. I'm just applying what is already there. Now we have found this angle. We need to find angle M, this angle here, and this angle L here. How are we gonna find angle M? Any idea? How are you guys gonna find angle M? Angle M, I can find it in many ways. I can see that there's U here. There's fun. I can say 120 plus angle M equal to 180. Here's my U. Another U. We're gonna say D is parallel to ML. Here's my U. Here's my U. Here's my U. And another way to solve for M is by saying, okay, I've learned the properties of parallelogram. Now, as per the properties of parallelogram, it says, okay, opposite angles of palm are equal. That means angle M is equal to angle E. And already angle E is 60. That means angle M will go to 60 degrees. Why? Opposite angles of palm are equal. Let's apply this property of parallelogram. Angle M is equals to angle E. Therefore, running over angle M equal to angle E because of what? Opposite angles of palm equal. This is your reason. You must split your reason. Therefore, angle M is equal to 60 degrees. You are done. 60 degrees here. Now, for the angle L now. How are you going to find L? How are you going to find L? Guys, how are you going to find L? How are you going to find angle L? I'm done with this one. Just for the angle L now, the last one, angle L. Angle L, I can find it again in many two ways. In three ways actually. The first way is by saying, okay, fine again. I can see that there's U here. U. I can use U. U. Level. I told you about fun. Cointerior angle. We're going to say angle E plus angle L. 60 plus angle L equal to 180 degrees. Then simplify for L. Another way to simplify for L is by saying opposite angles are equal of palm. That's the very same way you found M. I'm going to say angle D is equal to angle L. That means angle L is equal to 120 degrees. That's the second way. Opposite angles of palm are equal. That will be your reason. Another reason is by saying, okay, since we're now all four, and you said that all interior angles add up to 360 degrees. Revolution, the reason. Or interior of parallelogram. Now, we're going to use this one to simplify for angle. And why do we use it? Because we already have 3 angles. We have 3 known and 1 unknown. We can use that. We can use this one if and only if we have 3 known and 1 unknown inside the parallelogram or any quadrilateral. I hope you can hear me, guys. There. So now, therefore, if I have 3 known angles, I only left with 1. That means I can use it to find the last one. I'm going to say angle L plus angle G plus angle E plus angle M is equals to 360. Why do you say that? Because of what? Interior of palm equal to or add up to 360. Add up to 360 degrees. This is what is it you're gonna use. Then the value of angle L is unknown. The value of angle D is 120. The value of angle E is 60. The value of angle M is 60 again, equal to 360. Guys, equal to 360. And then you add the two. 120, 160 plus 60 is 120. 120 plus 120 more. And 60 plus 60 is 120. Then 120 plus 120 again is 240 again. Therefore angle L plus 240 equal to 360. Then I transpose this one to the right again. Therefore angle L is equals to 360 minus 240 is so it's going to be 120 degrees. That's my angle L, 120 degrees. Then you are done with angle number A. And you are done with number A. Let us go to number B now. Number B. So I'm done with number A. And yeah, I found those angles that they needed. Let's go to number B. We're still on this question. And I hope you can see it, guys. I hope you can see it. I hope you can see it, guys. Number B, it says Gucci. Number B, if DE is equals to 2 times DM, and ML is equals to 10 centimeter, and determine the length of the other sides of D, E, L, M. Okay. So number B gives if side DE, where is our DE? It's 2 times DM. Okay. 2 times DM. That means side DE is 2 times side of DM. This side, okay. 2 times DM. It means this side DE is equal to 2 times DM. Okay. And ML is equal to 10 centimeter. 10 centimeter. Yeah. Determine the length of the other sides of DLM. You need to find the length of EL, DM, and properly the length of DE. And how are we going to find that? We know that the opposite sides of palm are equal. That's what we know, yeah? Yes, that's what you know, guys. The opposite sides of palm are equal. Ne? The opposite sides of palm are equal. What does this mean, guys? What does this mean? It means what? I can find, let me just find DE. And DE is equal to 2 times. You don't want this variable DM. You don't want this DM. You want the length in numeric form of DE. Now, if you apply this, opposite sides of palm are equal. Okay. We already know obviously I know opposite sides are equal. Opposite sides of palm are equal. Okay. So that means this side is equal to this side, this side is equal to this side. Yeah. So here we have yeah, that's it. Opposite sides are equal. Yeah. Now we have ML is equals to DE. And DE. Yeah, DE. Why? Opposite sides equal. Yeah. Then what's the value of DE? DE is equal to 10 centimeter. DE is equal to 10 centimeter. Ne? DE is equal to 10 centimeter. Now we found DE here because of what opposite sides are equal. Now let us find DM. DM is equal to, DE, no, yeah, DM is equal to DM. So ML is 10 and DM is going to be DE is equal to 2 times DM and then equal divided by 2. Yeah, here's the thing here. And we said that, guys, DE and DM now. We said DE is equal to 2 times. I got this variable here. we want everything to be clear, but already we have DE equal to 10. DE is equals to 2 times DM. Now the value of DE is 10. We just found 10 here. We got a DM now. Then we go 2 times DM. We divide both sides by 2. We divide both sides by 2. Therefore, DM is equal to 5 centimeters. I know. Can you please indicate if you don't understand why do we say DE is equal to 2 times DM? And you have already found DM, which is 10 centimeters. Here's our DM, 10 centimeters. We want to find DM, this side, DM. Why do we use this way? Because we already know the side of D, which is equal to 10 centimeters. But DE cannot be equal to 2 times DM. You don't want this DM. It's a variable, this thing. To remove it, we must have go through this way of saying DE. Okay, DE, this length is equal to this. Therefore, if this is the case, then I can find DM through saying, okay, I found DE, which is 10. I can say DE is equal to 2 times DM. Which means the side D is equal to 2 times DM, as per the diagram says. Therefore, while the side of DE is 10 centimeters, here's my 10 equal to 2 times DM. Then to find DM, I need to be left with DM on one side as my subject of the formula. That means I'm going to divide both sides by 2, be left with DM on one side. Then DM is equal to 5 centimeters. Here's my 5 centimeter DM. And yeah, then the last one I can find, therefore, the length of DE here is equals to 10 centimeters. Why? Opposite sides are equal. Then DM, and can you please remove this one here? DM, DM. Now, DM is equals to EL. Why? Why do I say these two sides are equal? Because of what? Opposite sides of palm equal. Why? What? DM is equal to EL. Now, what is the value of DM? It's 5 centimeters. That means, therefore, EL is equal to 5 centimeters. Then you are done with this question, guys. Done. Done. 5 centimeters. Here's 5 centimeters. You are done with parallelogram. Next time, I will assist you with proving indeed this quadrilateral is a parallelogram. Okay? Next time, not today, guys. Next time, I'm gonna teach you how to prove this indeed is a parallelogram. Okay? This quadrilateral is a parallelogram. Thank you for now, guys. We will do another video explaining other quadrilaterals. Yeah, bit by bit. Thank you very much. So, guys, let us do question number 2. Ne? Yes. Question number 2. Yeah. Question number. Question number 2 is very simple. So we have a PS, we have TR, and the diagonals here. We have diagonals, then TQ, we have V, and parallel lines, obviously. Then you have diagonals that are bisecting. So you can draw it properly on your own. Yeah? Then you eventually create an angle here. Very simple. Yeah? Now, like I say, here's the statement. Okay? In the diagram, P Q R S is a parallelogram. Yeah? Then our PT is perpendicular to TQR. PT, yeah? Perpendicular to TQR. Then they're saying PT is equals to 5 centimeter. TQ is equals to 2 centimeter. PS is equals to 10 centimeter. Find VR. Simple, ne? It's very simple, guys, to find VR. How are you going to find VR in this case? So PT is 5 centimeter. 5 centimeter. TQ 2 centimeter. 2 centimeter. PS 10 centimeter. 10 centimeter. Now we're going to find VR. This side VR. Ne? Now let us apply our properties of parallelogram in this case, because they have told you this is a parallelogram, therefore you can apply these properties here. Simple, ne? Let's just apply them before you answer the question. Let's apply what do you know about the properties of parallelogram here. Yeah, let me just do something. Here we have the first one, opposite sides of PAM are equal. Can I use this first principle to answer this question or to fill up my diagram? Yes. If that's the case, then I know if I have P S here, R, this one, ne? This is my parallelogram here. I can't say P. Here we said that opposite sides are equal here. Therefore, PS is equal to QR. You don't say PS is equal to TR. No, this side is longer than PS, but PS is equal to QR. I hope you can see it, guys. So PS is equal to QR. Why? Opposite sides of PAM equal. Yeah? Therefore, if PS is equal to QR, therefore QR is equal to 10 centimeter. 10 centimeter here. Ne? Now, how can we find VR here without wasting any time? I can see that here's my VR, ne? And I literally cannot do anything, ne? But it's simple to find VR, guys. It's very simple. Now, the simplest way to find VR is by saying, okay, VR is part of PR. Yeah? VR, this length, is part of PR. Yeah? And PR, these are diagonals. And we talk about diagonals bisect. And if diagonals bisect, that means they share the length. Yeah? That means PV and VR shares the length of PR, the whole segment PR. That means the length here of PV plus the length of VR equal to the length of PR. The length of PV plus the length of VR equals to the length of PR. That's how it rolls. Then how can I find VR? One of the ways to find the VR is by firstly finding the length of PR. I have 90-degree angle here. I have the length of PT. I have the length, perhaps I have the length of TR, because the length of TR here, you're going to add 10 plus 2 is going to be equal to 12. That means the length of TR here is going to be equal to 12. 10 plus 2, 12. And here, PT, TR, I need to find PR, Petrogas, because I have 90-degree angle here. Yeah? So now, therefore, PR squared is equals to PT squared plus TR squared. Why? Pythagoras. Now, what is the value of PR? I don't know. PR squared is equal to, what is the value of PT? 5 squared. What is the value of TR? 10 plus 2 is 12 squared. Here. 5 squared is 25. If you put this on a calculator, it's going to be 169 here. Then PR squared, square root on both sides. Then PR is equals to 13 centimeter. I hope you can see it, guys. The length of this side, all of it, equal to 13 centimeter. Now I need to find the length of VR. How am I going to find VR? Since we know the diagonals bisect, that means PV and VR are going to share 13. They are going to share 13. Then what is the half of 13? Is 6,5. That means therefore VR is equal to 6,5 centimeter. 6,5 centimeter. And then what is the length of PV? Also 6,5 centimeter. What's the length of PR? 6,5 plus 6,5, 13 centimeter. Then you are done with finding VR. Use these properties to simplify problems here. Very simple, guys. Use these properties to find your values here. You'll be okay. Let us do another example about parallelogram. Let's do another example about parallelogram. 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 Example number 3. Example number 3. I hope you guys are still here. Now, example 3. Example 3. Example 3. Example number 3. Example 3. It's so simple. Example 3 is so simple. So you have A, B, C, and D. And A, okay, 2x minus 8. D, okay, 2x plus 10. And now the question says determine the sizes of the interior angles of parallelogram. Guys, they are telling you this is a parallelogram. They are telling you that this is a parallelogram. They are saying this is a parallelogram. Now you come back here, you apply this. What do you know? You know the opposite sides are parallel. Parallel. That's what you know. You know again the opposite sides are equal. And now, how can I find? Here you need to find. Here they say we determine the size of interior. We need to find the size of angle A, angle D, angle C, and angle B. But I have variables here. I have x here. I have x here. How can I find angle A, B, C, D without involving that x there? Very simple, ne? So simple, ne? Yes. Now let us find. Our first thing first, we need to find this variable x. That's what we need to find. We need to find x there. Now let us do that. So we have this, and here you know what fun. Maths is fun. Since we know there are parallel lines here, I can use fun, and I can say I have u. U can be used, and here's my u. Here's my u, guys. Here's my u. Here's my u. So this u covers angle A and angle D. So angle A plus angle D equal to 180. Angle A plus angle D equal to 180. Co-interior angles. What's the value of angle A? 2x minus 30. What's the value of angle D? Plus bracket 2x plus 10 equal to 180. Then you solve for x again. Now you simplify again. This positive is going to multiply each and every term inside the bracket again. Positive times positive is positive, positive times positive is positive again. Simple. 2x plus 2x, 4x. Like terms again. Negative 30 plus 10 is negative 20 equal to 180. Then I transpose this negative 20 to the right again. It's going to be 180 plus 20 is 200. Then 200 divided by 4 is 50. Then you are done with finding your x. You are done with finding your x. Your x is 50. I'm going to remove it. So I don't have a space, hence I'm going to remove. Just write it down. Your x is 50. Yes, your x is 50. We just found x and you need to find all interior angles. So now, therefore, angle A is equals to 2 times 50 minus 30. Remember, we just found x here. You just substitute it. Where you see x, we put in 50 to find angle A. 2 times 50 is 100. 100 minus 30 is 70 degrees. That's the value of angle A, 70 degrees. 70 degrees, angle A. 70. Angle D, I can find it also. Angle D is equals to 2 times 50 plus 10. 2 times 50 is 100, 110. 110, angle D. 110. Now, I'm left with finding B and C. How can I find B and C? I can find B and C through the use of fun. Here's my U. Here's my U. Here's my U. My U starts from D to A to B to C. D, A, B, C. D, A, B, C. I can say angle A plus angle B equal to 180 co-interior. Then 180 minus 70 is 110. I'm done. But I know in parallelogram, the opposite sides are equal. The opposite sides are equal. That means angle B is going to be equal to angle D. Why? Opposite angles of palm equal. Therefore, angle B is equal to 110. 110. I can find angle C in many ways. I know the opposite angles are equal. That means angle A is equal to angle C. I can use that one, or I can use fan U, co-interior angles. Here's my U. I can say 110 of angle D plus angle C equal to 180 degrees, and say 180 minus 110 is 70. I'm done. Another way I can use is this one. All interior angles add up to 360 degrees. I can say angle A plus angle D plus angle B plus angle C equal to 360 degrees. So I can find C in that way. Angle A plus angle B plus angle C plus angle D equal to 360 degrees. Interior of palm add up to 360 degrees. It will depend on what you write and get. What is the value of angle A? 70. What's the value of angle B? 110. C, unknown. D, 110 now equal to 360. Then I'm going to transpose each and every constant to the right. 70 to the right, 110 to the right, 110 to the right. Then I say 360 minus 70 minus 110 minus 110 equal to 70. Therefore angle C equal to 70. I'm done. Literally done. The last question about parallelogram before we move to rhombus. Last question about parallelogram before we move to rhombus. Last example about parallelogram before you move to rhombus. Before you move to rhombus, ne? Here's the last example, okay guys. Very simple and straightforward, this one. This is the easiest question I've ever encountered. This is the easiest question I've ever encountered. Yeah. So you have P, Q, S, R, ne? Then this side is equal to this one here. This one is 60 degrees here. And you have S1, 2, Q1, Q2. Then now the question says what P, Q, R, S is a parallelogram with angle P being equal to 60 degrees and PQ is equals to PS. Calculate the sizes of R1, S1, Q1, Q2, and S2. So you need to find the sizes of those angles. How can you find the sizes of those angles, guys? Very simple, ne? So I'm going to find R1, S1, Q1, Q2, and S2. So now, how can I find R? Actually, it's not R1 here. I think it's angle R, not R. There's no R1. Angle R, here's our angle R. How can I find angle R? The first one, angle R. How can I find angle R? I know, good, this is a parallelogram. I come back here. What does parallelogram say about its angles? Opposite angles are equal of parallelogram. That means angle P is equal to angle R. That's parallelogram, guys. Therefore, angle P is equal to angle R. Why? Why do you say that? Because opposite angles of palm are equal. Therefore, angle R is equal to 60 degrees. Now, we have 60 here. Simple. Hutu, can you find S1? Can you find this one? I think is tricky, but hopefully you guys will get it. Since well now, guys, you have done with triangles, and you've done with isosceles triangle, isosceles triangle. Yeah, it says if the two sides are equal, therefore the adjacent angles are going to be equal. Okay, this is the case. These two sides are equal. That means angle S1 is going to equal to angle Q1. That's what it says. Isosceles triangle. Yeah, I hope you understand me, guys. So if you have an angle inside an isosceles triangle, yeah, if you have an angle inside an isosceles triangle, yeah, that angle, how will you find S1? You will say angle P, and here we see well now. Here number 1, number 2, it says and here we said that in a triangle, if the opposite sides are equal, therefore the adjacent angles are going to be equal. That means angle S1 is going to be equal to angle Q1. And here, why? Angles opposite equal sides. I hope you did isosceles triangle before you can come here. I hope you dealt with such explanation. Now, if this is the case, then I need to find S1. My aim is to find S1. Therefore, I'm going to say angle P plus. Remember, guys, we said that S1. Okay, let me just put it like that. I'm going to say S1 plus Q1 is equals to 180 degrees. Why? Interior of triangle. That's the reason interior of triangle equal to 180 degrees or add up to 180 degrees. Hence I say that. Then for angle P I have 60 degrees. What is the value of S1? I don't know. S1 plus Q1 equal to 180. Therefore S1 plus Q1 equal to 180 minus 60 is 120. And therefore, if we have 120 here for S1 plus Q1, we want to find S1. Since right now we said S1 is equal to Q1, that means these two angles, S1 and Q1, are going to share this 120. And you only do this if and only if you are given an angle inside a isosceles triangle. If you are given one angle inside an isosceles triangle, you can divide. You can literally share the two angles with this 120. Then therefore, S1 is going to be equal to 60 degrees. I said 120 divided by 2. Why 2? Because there are two angles here, S1 and Q1, that are going to share 120. Even Q1, is going to equal to 60 degrees. S1 is equals to Q1, 60 and 60. If I say 60 plus 60 is 120, therefore, if I add S1 and Q1, they're going to give me 120. Then each angle equal to 60 degrees. 60 plus 60 is 120. Therefore, here we're going to have 160 and 60. I've answered S1 and Q1. I'm left with Q2 and S2. I hope you can hear me, guys. Now, if this is the case, remember, if the three angles are equal, therefore, the three sides are going to be equal. Equiangular. I hope you have learned about equiangular. It's not something new, okay, guys? Yes. It's not something new. Now, we need to find Q2 and S2. Where are they? Here's my S2 and here's my Q2. Okay? Remember, the opposite sides of palm are parallel. Parallel lines. Okay? Opposite sides are parallel. This side is parallel to this one. This one again is parallel to this one. So to find S2, I can see that there's Z here. Here's my Z. And here, alternating angles. Alternating angles. That means I need to find Q2 and S2. So to find, I can find S2 through this angle of Q1. That means Q1 is equals to S2. Why? Alternating angles equal, such that PQ is parallel to SR. And therefore, S2 is equals to 60 degrees. We have 60 here. How to find Q2? Q2, I can find it. And we need to find Q2 and S2. I found S2 and left with Q2. I can find Q2 by saying, there is again Z, alternating angles again. Alternating angles, Z is my Z. I can find in that order, or I can say, okay, I have two known angles inside my triangle. I have two known angles inside of my triangle. Therefore, I can use interior of triangle to find Q2 inside this triangle. So I can say angle Q plus S2 plus R equal to 180 degrees. Why do you say that? Interior of triangle add up to 180 degrees. Then what's the value of Q2? Q2 plus S2 is 60, angle R is 60, equal to 180 degrees. Therefore, I'm going to transpose this 60 and 60 to the right and say 180 minus 60 is 60 degrees. This is my final answer, guys. Q2 is 60 degrees. Then you are done with such questions of parallelogram. I hope you understand what's happening here. In the next video, we're going to deal with rhombus. Thank you very much, guys.